Hello guys, good morning. You are welcome to my YouTube channel, the Space Tutorials. As you all know, my name is Tutor Joseph. In today's video, I shall be solving more questions on heat energy. In our previous class, which was last night, I told us that I shall be solving more questions on heat energy today. And last night we discussed the meaning of heat energy, that is heat energy, specific heat energy, latent heat of fusion, latent heat of vaporization. Let me quickly do a little revision before I jump into the question I have on the board. Now I said that the process of measuring heat lost into the environment is done through a process called what? Calorimetry, alright? And it is measured using what? The calorimeter. There are four types of calorimeter. We have the glass calorimeter, we have the ice calorimeter, we have the regnant calorimeter, and we have what? The bomb calorimeter. Then I laid emphasis on bomb calorimeter. I said it is that calorimeter that is used to measure heat of combustion. Alright? And I also said that the process of reducing heat lost into the environment or surrounding is called what? Lagging. That is Lagging. The process of reducing heat lost into the environment is called what? Lagging. And we also said that heat capacity means the quantity of heat required, needed, or supplied to raise the temperature of a substance by 1 Kelvin. That is it. I said it is the heat required, needed, or supplied to raise the temperature of a substance by 1 Kelvin, or to raise the temperature of a mass of a substance by 1 Kelvin. That is what heat capacity. Then I said that specific heat capacity means the quantity of heat required or needed or supplied to raise the temperature of a unit mass of a material by 1 Kelvin, which means that the difference between heat capacity and specific heat capacity is what? The unit stated in the definition. All right, it is the quantity of heat required, needed, or supplied to raise a unit mass of a substance by 1 Kelvin. All right, by 1 Kelvin. That is what specific heat capacity. Then from there, we also discussed what is called latent heat. All right, latent heat means the quantity of heat required, needed, or supplied to change the mass of a substance at constant temperature and pressure. Please, while stating the meaning of latent heat, it is worthy of note that you include constant temperature and pressure because they do not what? Change. I recap. Latent heat means the quantity of heat required, needed, or supplied to change the mass of a substance as at constant temperature and what? Pressure. That is what? Latent heat. We now have specific latent heat of fusion and specific latent heat of what? Vaporization. Now the first one is specific latent heat of fusion means the quantity of heat required or needed to change a unit mass of a substance called solid, all right, in melting point to change into liquid. All right, whenever you hear the word eyes in a given question, take your mind to what? Specific heats, that is specific latent heat of fusion. All right, the quantity of heat required or needed to change a unit mass of a substance called solid in its melting point, all right, to turn into what? Liquid at constant temperature and what? Pressure. You call that what? Specific latent heat of fusion. Eyes, latent heat of what? Fusion. The other one is what? Latent, that is specific latent heat of vaporization. I said it is the quantity of heat required or needed to change a unit mass of a substance called liquid in its boiling point to change into gas at constant temperature and what? Pressure. It is very, very important. So those were the various terms we treated the other day. That was last night. And I also rounded up the class by solving striking questions on the topic. So today we'll be solving more questions on it. You have on the board a question. They said a copper calorimeter of mass 60 kg contains 100 kg of oil at 20 degrees Celsius. A piece of ice at 0 degrees Celsius and mass of 25 kilogram is added to the oil. Calculate the amount of the ice left when temperature of the calorimeter and its contents becomes steady at 0 degrees Celsius. The word steady is equilibrium temperature or final temperature or stable temperature. All right. Now they gave us the specific heat capacity of copper to be 400. We are given specific capacity of oil to be 2400 and specific latent heat of ice to be what? That is 33,000. That is 336 what? Thousand. So this is what you have. Now it means we have to calculate for what the amount of ice left when the temperature of the calorimeter and its content becomes steady at 0 degree Celsius. So from this question, we are comparing two entities. One, the copper calorimeter, and secondly, oil. All right, two entities, okay. And again, eyes as well. Eyes, three entities. Now we have to. The mass of eyes wasn't given, was it? Okay, it was. So we are just to calculate the amount of eyes remaining. All right. So which means that what I will get, we subtract it from the mass of eyes given, which was where is it again? This was the mass given, so we have to subtract whatever we get from this. Okay, let's get started. Now the mass of copper the mass of copper is equals how many kg? 60 kg. All right, whenever the mass is given in gram, all right, it is very important you convert from gram to what? Kilogram. In doing that, you have to divide by 1000. Now the next one is mass of oil. You have it to be what? 100 kilogram. Then the next one is mass of ice. You have it to be what? 25 kg. 25 kg. Is that not correct? Okay. And mass of 25 is added. Is added to the oil. Calculate the amount of ice left. Good. So from here, in doing this, all right, first thing first, I can say Q1. Now this Q1 is for copper. I'll say mass of copper, all right, specific capacity of copper, and temperature change of what? Copper. So which means that Q1 is equal to mass of copper is 60 times the C given, that is the specific heat capacity of copper was given as 400 times temperature change, which is Q1 minus 0. So the Q1, that is theta 1, right? Which means it's what? Where is the, that is 20 minus 0. That is 20 minus what? 0. Doing that, I have Q1 equals 6 times 4 is 24, all right? 24 times 2 is 48. I will have 48,000, all right? 48,000 joules. Let me do it again. 6 times 4, that is what? 24. 24 times 2, I have 48. How many zeros? 1, 2, 3. Okay, 4 zeros, sorry. Alright, so this is what? Copper. Now, that is the heat lost by the copper. The heat lost by the copper. Now, the next one is going to be the heat lost by the oil. Alright, so I'll say Q2. Q2 is equals mass of oil. Mass of oil. Then specific capacity of what? Oil. Then temperature of what? Oil. Like that. Now, the next one is the mass of oil given was what? 100 kilogram. 100 kilogram. Okay, there's no need to write this kilogram, please. Then times, where is it? Oil? 2,400 times 20 minus 0, of course, is what? 20. All right. So Q2 is equals, is it 1? Okay, it's 100, sorry. Now, what do we do from here? We'll say 24 times 2, we have 48. 48, so 0, 0, 0, 0, 0. That's 1, 2, 3, 4, 5. So that is what? For the heat lost by the oil. Okay. Now, then as for, what's it called now? As for that of the eyes, you say now Q total is equals MF. All right. So we are looking for the mass. That is, we're looking for the mass, and that of eyes was given to be what 30. That is 336 what thousand. So when I have that Q total is equals mass, that is 336, how many zeros? 000 mass. All right. So which means this, I'm going to be relating the eyes with what I've solved here. So it means to get my, okay, I think I can wrap up this place now. So just follow it bit by bit. So it means that MLF is equals Q1 plus what? Q2. Alright, MLF, which is the Q total, equals what I've gotten in Q1 and what I've gotten in Q2. Alright, so it means that the mass which we are looking for, then that is, I think we got it here before, to be 336,000 equals Q1 is 481234 plus the Q2 is 4848. How many zeros? 1 2 3 4 5. 1 2 3 4 5. All right, that is what. So what do we do next? We have to add up everything. All right, excuse me, let me get calculator please. So which means we have 1 2 3 4 5. Hope I'm sure about that. 1 2 3. Okay, we have 48 plus 8 1 2 3 4 5. I have don't forget you have your mass attached. Mass, so equals, divide both sides by 33600. 33600. All right. So from here, the food is almost ready. So this will go into this. So mass now becomes 52. This plus this, I had it to be 528,000. So divided by 336,000 equals, I had 15.71 kilogram. 15.71 kilogram. Now for me to get the total mass, the amount of mass remaining, it means I'm going to be subtracting this from this, which means that the mass, okay, mass left is equals 25 minus what? 15.7. So we now have that 25 minus, I think you see the options here. You have 15.71 in the option. So if it was to be jam, you just pick it and say you have killed jam. You say like they have killed you indirectly. So they said the mass left when, that is total mass left when this was added. So it means we are going to be saying 25 minus 15.7 equals, so mass left is equals what? 9.3 kg. Alright, so the answer to this idiot question is 9.3 kg. So that is what you have the answer to be. It is very, very simple. Just follow it step by step. The first thing you do, because of how complex the questions usually come out, that is relating different entities, it's good to just write out their parameters, after which you write their formula. Then after that, you can now start substituting your formula, your parameters, and from there you'll be good to go. All right, so that is number one. Let me solve one more question before I call it a day. Okay, I have a question here. They said an electric heater Okay, an electric heat of 60 watts. 60 watt. What does that tell you? Power is measured in watts. Power is measured in watts. The work done is measured in joules. Quantity of heat gotten is measured in what? Joules. And I said an electric heat of 60 watts. It means that watt power is what? 60 watts. Is used to heat a metal block mass 20 kg. All right, so mass of block equals what? 20 kg. Time, they said 5 minutes. Time was given in minutes. All right, so to convert to seconds, you say 50 times 60. You're going to be having 300 seconds. 300 seconds. Please take note. Let me say this. I said it in our previous class. Whenever the options are given in minutes, please, you don't have to convert. If the options are in minutes and the time occurs as minutes, you are not converting. But if the options are in seconds, you have to convert from minute to seconds. And if it was to be a theoretical question, you must convert from minutes to seconds. Okay, take note of that. And calculate the specific capacity of metal block if it rises in temperature. So which means that the temp. Oh God, I refill these markers. So which means that the temperature is equals to 20 degrees Celsius. Now from here, food is ready. Now since you have, in our previous class, I also deduced different formulas from Ohm's law, from electrical power, from electricity, from different dimensions. Okay. Now for what we have, it means that we are relating P to T. It means that PT is equals MC change what? Temperature. MC change in temperature. So power is 60. Time is what? 300. Time is 300. And what is the mass from the question? The mass. The mass is what? 20. Then times C. That is what we are looking for. Then times 20 again. So this times this. 3 times 6 is 18. You have 1, 2, 3 equals 20 times 20. You have 400 C. Because 2 times 2 is 4. So 0, 0. To divide both sides by 400. So this will go into this. Alright? Is that not correct? Yes, it's very, very correct. So 2 into 4 is 2. Alright? 2 into 180 is 90. So you have 2 into 2 is 1. 2 into 90. Is it 90? 90 plus 90. Yes, 90. So 2 into 2 is 1. 2 into 90 is what? 45. Alright, so which means that specific capacity now, is that not what we're looking for? Which means that our specific capacity is what? 55 joule per kilogram Kelvin. Alright, please let me confirm the answer using the calculator. So I have 18123 divided by 400. So it is very correct. So the answer is what? 45 joule per kilogram Kelvin. So please take note of that. If I don't want to write the SI unit like this, I can see that specific capacity is what? 45 kilo, okay, 45 joules per kilogram per Kelvin, like this. I can also write it like this, okay? Or no, there's no need to write this. So kilogram per Kelvin, that is per Kelvin. You say joule per kilogram per Kelvin. Joule per kilogram per Kelvin. So what I have here is something as what I have here. Alright. So please take note of that. It is very, very important. Okay, let me solve one more question. Before I call it. To this. Now they said, okay, I solved this question last night. What is remaining for me to solve? Okay, they said, please, I believe what I've just solved is understood. Write out the parameters, write out the formula, you begin to what? Impute your parameters, you get the answer. Very, very easy. Now the next one is, which is the last one for now, I'll solve more questions on this topic, more questions. All right. Now they said a student eats a Thanksgiving dinner that totaled 200 2,800 kilocalorie. To have better math as well. Kilocalorie. He wants to use up all the energy by lifting 20 kilogram. The mass is 20 kilogram. A distance. Let me please. Mass 20 kilogram. Then distance h is equals what 1. So they gave us g to be what 9.8 meter per second squared. We said, let me repeat the question again. A student eats a Thanksgiving dinner that totaled 2,800 kilocalorie. He wants to use up all the energy by lifting 20 kilogram mass of a distance 1.0 meter. How many times must he lift the mass? How many times must he lift the mass? So from our potential energy, we have to be mgh. Alright, so PE, mass given is 20. Acceleration due to gravity given is what 9.8. Then times what 1. So I have 20 times 9.8 equals, I have the PE to be what 196 joules. 196 joules. Now this idiot is in a kilocalorie. I have to convert to what calorie by multiplying it by 10. So I have 2800 kilocalorie, and that becomes what 2800 then times 1000, 1 2 3 calorie. All right, so we cannot solve with this. Now if one calorie is equals to 4.186. If one calorie is equals to 4.186, all right. So how many of these will I have? How many calories will this one give? 2, 8, 1, 2, 3, 4, 5 x. So you have to cross multiply. All right. So we are not true. In cross multiplying becomes x equals this times this divided by 1. So the same thing. So I'll say 4.186. Please take note. 1 calorie is equals to 4.186. All right. Please take note of that. So I have 2 8s 1 2 3 4 5 times 4.186 equals, I have 117 20800. All right, 2800. So, and they said how many times would he lift up the mass? So in doing that, we have to calculate the number of joules we have here. In doing that, it becomes 117200800 117, that is 11720, okay, 0800 divided by, we want to know the number of joules present here, so now have divided by 196. So what will you have? You have 11720 equals, okay, divided by 196. And we have it to be 59800. So it's going to be 5,000, that is 59,800 times. So this one is approximately 60,000. All right, I can, oh yes, I will now have to be what, 60,000. All right. So please This is the idiot answer. So in our next class, we'll be solving more questions on this topic. Thanks for watching. Do have a wonderful day. Please endeavor to subscribe, like, share, and comment, and also forward it to your friends who are in need of this video. Do have a wonderful day. Thanks for watching.